Knowing where violent events and instability are increasing is essential to understanding your area of responsibility. But what if we knew when they would increase? What if we knew what month in the future the largest spike in violence would occur? What if we could move from being descriptive and reactive to being predictive and proactive to meet an ever-changing security picture? Thanks to the Armed Conflict Location Event Dataset, or ACLED, the map on our left shows conflict events in Africa over the last 10 years. The map on the right is a history of these events used to estimate the future. By selecting a pop-up, the forecasted value for this location over the next year is broken down month by month, predicting out a whole year of violent conflict and instability. How did we get here? Let's take a look. The first problem is the enormous number of events. There are too many points on this map. What we want to do is prioritize clusters. In ArcGIS Pro, we have a tool, density-based clustering, that separates significant clusters from noise. Isolating these clusters is the first step to moving from being reactive to predictive. Once the clusters are separated, we can simply select by location, and now we have our conflict of events in a much more manageable size. Now, another question arises, and this one is more pointed. What about time? How do we understand the past and the present to forecast the future? In ArcGIS Pro, there are a couple ways to handle time. The first is the creation of a space-time cube. Now, what is a space-time cube? What happens when we create a space-time cube is we're summarizing data into bins. Imagine it just in a 2D space, summarizing all the points on our map into easy-to-define polygons. This is where time comes in. We add time as a third dimension to construct that three-dimensional cube. Time becomes our z-value, and now the changing value of that bin can be seen over time, starting in the year 2010 to the present day, broken down month by month. There are a couple ways to visualize a space-time cube. One way is 3D. This is a voxel layer. Each column is a location, and the further you move up the column, the further you move forward in time. The base of the column is January 2010, and the top of the column is the present day. The color intensity from yellow to red represents the intensity of conflict and instability. From a bird's eye view, I am not seeing any huge trends jumping out. But pivoting to the northern coast of Africa, specifically Libya, we see two cities headed in markedly different directions. The city of Benghazi on the left and Tripoli on the right show similar patterns of violence and instability throughout the course of the 2010s. By slicing the voxel, I can see the history of these two cities over the past 10 years. Both cities have similarities throughout the mid-2010s, but as we reach the present day, Benghazi decreases in violence while Tripoli shows an explosion. This corresponds with the recent LNA offensive to take back Tripoli this past spring and early summer. As an analyst, I want to isolate specific conflict hot zones and look through space and time to identify how these zones have changed. Changing the symbology of the voxel layer allows me to quickly visualize where in space and time conflict hotspots have arisen. By adding a control point and a transparency function, I can now see not only in Libya where hotspots are, but across the entire continent of Africa. 3D is not the only way to visualize the space-time cube. We can also visualize it in 2D. We're going to flatten out the space-time cube, and it's going to show us upwards or downward trends in our data. Purple is an upward trend, and green is a downward trend. Africa as a whole appears to be on an upward swing in violence and instability. The only area that has seen a marked decrease is Egypt, and specifically near Cairo. Selecting the pop-up shows a chart of our data over time. These are all the conflict events from 2010 to 2020, but our data stops in September of 2020. We're still reacting, still describing what has already happened. we haven't yet begun to be proactive and predictive. Let's use the time series forecasting toolbox and begin estimating where violent events are going to increase. Using the history of each location, we can begin to forecast the future value of that area. The curve fit forecast tool simplifies the complex nature of modeling violence into a single tool, so predictive modeling isn't locked away behind obscure statistical formulas, but democratized and usable to solve problems right now. The curve fit forecast tool will fit a curve to our data. If we knew violence was growing exponentially, we could choose that curve type in the tool, but the data shows variance, with some areas fluctuating wildly compared to others, so we'll let the tool decide what curve for each location. When the tool runs, critical information will be contained in the pop-up. Examining the Lake Chad Basin shows a parabolic curve was chosen, and violence is broken down into month-by-month intervals, not only for the past 10 years ending in September, but also forecasted out for an entire year to September 2021. Violence appears to be increasing over the next year. Assisting our partner country to deter violence or deploy resources here can hopefully prevent violent activity from ever increasing. However, this data displays seasonality, such as the rainy or dry season, and other smaller, more acute cyclical patterns. There are going to be ebbs and flows in violence. To model this variation, there are other tools which deal more deftly with seasonality. The exponential smoothing forecast tool considers seasonality location based on the events and when they happen. The pop-up will be similar to the curve fit forecast tool. However, the tool will display the seasonality of the location as well as a confidence interval. In the Lake Chad Basin, there is a 3-month seasonality. We also see our original value in blue, the fitted value of our forecast, and the confidence interval for that forecast. Now, we've run a couple models. Now we can return to the map from the beginning. Let's evaluate each model we've run and see which one was chosen for each location. Deciding which model is best is a tough question to answer. But within the time series forecasting toolbox, the Evaluate Forecast by Location tool takes into account which model worked best for each location, then returns that information in a pop-up. In the Lake Chad Basin, exponential smoothing was chosen as the best possible forecast for this location. Focusing our resources and supporting our partner nation in this area will hopefully lead to a decrease in prevention of violent activity before it ever happens. Let's take a look at an area we may not have previously considered through descriptive analysis. An area that the time series forecasting tools identified for us as a possible hotspot in the future. The border of Mozambique and Tanzania was relatively quiet up until late 2017. That was until ISIS moved in. The Evaluate Forecast by Location tool selected an exponential growth curve as the best possible forecast for this location. And the time series forecasting tools have identified this as an area that we should focus our resources on and examine how we can assist our partner nation. We've gone from being reactive and descriptive to predictive in a few short steps. We've identified not only where violent events are happening, but possibly when in the future they'll occur. We can disseminate this information out to better allocate our resources and alert our partner nations to prevent these future threats from ever occurring. Thank you.